are you doing today?
We're doing fine, thank you.
How are you doing, Kanani?
I'm doing fine too, thank you. You remember that we did an experiment on digestion in our mouth, right?
Yes.
And we said that food is broken down into smaller pieces by our teeth, and the enzyme amylase acts on starch to convert it into simple sugars.
Yes, we did that experiment. We saw that saliva contains the enzyme amylase.
We all know the use of saliva in our mouth, right?
Yes.
But what is the use of breaking food down to smaller pieces?
Well, before we try to answer that question, let's do this following experiment. Here I have a cube of plasticine, and all its sides are 4 centimeters. And as you can see, it has 6 sides since it's a cube. So now let's try to calculate the surface area or the total surface area of this cube. To do that, since all its sides are equal, we can take one side's surface area and multiply it by 6.
So to calculate the surface area of one side, which is 4 centimeters,
Yes.
multiplied by 4 centimeters, which is total surface area equals to 4 times 4, which is 16 centimeters square.
But Arsema, that's not the total surface area. Since it has 6 sides, we have to multiply 16 by 6 in order to get the total surface area.
Oh, I'm sorry.
Okay, so multiply 6 by 6.
So the total surface area will be 16 centimeters squared multiplied by 6, which gives us 96 centimeters squared.
So let's measure this. Can you please mark it on the 2 point?
Now we have 2 smaller pieces. All 2 large sides are 4 centimeters long and 4 centimeters wide. And the other 4 smaller sides are 4 centimeters long and 2 centimeters wide.
So now will you please calculate the surface area or the total surface area of these 2 cubes?
Yes, sure. To calculate the surface area of the large sides, we have to multiply 4 by 4, which is 16 centimeters square. But since we have 2 large sides, we have to multiply 16 by 2, which is 32 centimeters square.
And to calculate the smaller sides, we have 4 by 2, which gives us 8 centimeters squared. And we know that it has 4 small sides, so we have to calculate 8 times 4.
That's 32.
You should write it again. Yes. So now, as we have seen, each half of the cube has a total surface area of the large sides plus total surface area of the small sides, which is 32 centimeters squared plus 32 centimeters squared, which gives us 64 centimeters squared. The other half of this cube also has the same total surface area. So the total of the two will become 64 centimeters squared plus 64 centimeters.
128, right?
Yeah, together it is 128 square centimeters. So when we compare it before we cut it and after we cut it, before we cut the cube, it was 96 centimeters squared, but after we cut it, the total became 128 centimeters squared.
It increased, right?
Yes. So now let's compare the two calculations. As we can see here, this is the total surface area before we cut the cube. And as we can see here, it's 96 centimeters squared. But after we cut it, since there were two halves, one is 64 and the other is also 64, when we came up with the total, it became 128 square centimeter, which means that the total surface area increased as we cut it into two pieces.
That's correct.
So now let's cut this two again into two equal parts. I'll cut it for you.
Now we have 4 smaller pieces, and for each piece we have 4 larger sides, which is 4 by 2, and 2 smaller sides, which is 2 by 2. And to calculate the surface area, we have to multiply 2 by 8 plus 2 by 4 plus 4 by 8, which gives us
40.
Yes, that's 40 centimeters square. Since we have 4 pieces, we have to multiply 40 by 4, which gives us 160 centimeters squares.
Ashima, can you please compare these two?
The first one? Okay.
The first one with this one.
The first one was 96 centimeters square, but after we cut it into 4, it became 160 centimeters square.
So it increased.
Yes, it's increased.
Now again, let's cut these 4 pieces. Let's cut these 4 pieces into 2 equal parts so that we can get the sides, which are 2.
So now we have 8 cubes with equal sides, right?
Yes.
And the side is 2 by 2, as you can see. So the surface area of one side is 4.
Yes.
And since it has 6 sides, we multiply 4 by 6. It becomes 24 centimeter cubed. Squared, yes. But this is the total surface area of 1 cube. To get the surface areas of 8 cubes, we multiply it by 8.
24 multiplied by
8. 192
centimeters squared.
It's still increasing from when we compare it from
The first
the
one.
last one and the first one and before that.
Yes, you're correct. Okay, now let's look at our data and reach a conclusion.
We can see here that when the original cube is cut into smaller pieces, its surface area will increase.
Yes, that's right. But how does this help digestion?
Well, I think it's really clear now. As the surface area increases, the enzyme, the space in which the enzyme will act on will also increase. So that's making the rate of digestion increase as well.
Yes. While we're still on surface area, let's see the relation between surface area and volume of an object.
Let's assume there are 3 cubes, and all sides in cube A are 4 centimeters, and in cube B are 3 centimeters, and the last cube, cube C, are 2 centimeters.
Now let's calculate the surface area, volume, and surface area to volume ratio of each of the cubes. As we have said before, cube A has sides of 4 centimeters, and since all its sides are equal, let's calculate the surface area of one side and multiply of one side of the cube and multiply it by 6. That means 4 times 4 multiplied by 6, which is equal to 96. Yes, 96 centimeters squared. And then when we look at the volume, we multiply the height, the length, and the width.
Yes.
So 4 centimeter times 4
Since it's a cube.
Yes, that times 4 centimeter.
Yes.
Which is equal to 64 centimeter cubed. When we look at the surface area to volume ratio of cube A, it would be 96 to 64. 264, which means 1.5 to 1. Now let's look at cube B. For the surface area, as we have done before, we calculate a single side and multiply it by 6, which means 3 times 3
Multiplied by 6.
That would be 54.
Yes.
Now let's calculate the volume, which would be 3 times 3 times 3 centimeters,
27.
which is equal to 27 centimeter cubed. So now when we calculate the surface area to volume ratio, it would be 54 to 27.
54 to 27.
That would be 2 to 1.
2 to 1.
Now let's calculate cube C. Cube C has sides of 2 centimeters. So that would be 2 times 2 times 6, which is 24 centimeters squared. And then the volume would be 2 times 2 times 2 centimeter cubed. And then this would be 8 centimeter cubed. So when we look at the surface area to volume ratio of this, it would be 24 to 8, which is 3 to 1. Now, as we can see here, the surface area of cube A was 96 centimeters squared. The volume was 64 centimeter cubed. And then when we calculated the surface area to volume ratio, it came 96 to 64, which is 1.5 to 1. Cube B has 54 centimeters squared surface area, volume which is 27 centimeter cubed, and the surface area to volume ratio is 54 to 27, which is 2 to 1. And then cube C, which has sides of 2 centimeter, is the surface area is 24 centimeter squared. The volume is 8 centimeter cubed, and then the surface area to volume ratio is 24 to 8, which is 8 to 1. 3 to 1. Yes. So, do you see any pattern here?
Yes. Yes. As the size of the cube decreases, the surface area to volume ratio increases.
I can also see that.
Yes. This one decreases, but this one increases.
Okay. So this is a simple arithmetic case scenario here. Why are we doing this in biology class?
Well, when we look at how many of the polar animals are adapted to their environment, which is very cold, when we look, for example, when we look at the polar bear and the seal, they're very large. So let's try to relate this with our observations. What can you say?
Well, according to our observations, large animals have smaller surface area to volume ratio. This means that if they have to lose heat from the body, they can lose it all through a small area.
Yes,
Yeah, in other words, they lose less amount of heat to the environment than the smaller animals.
Yes, that's the whole idea. This explains why polar animals are very large.
Yes, but we have to try to see it from different angle. Cells are very small structures. So, considering our observation, is being small an advantage or a disadvantage?
I guess this needs time to think. So let's just go home, think about it, and meet some other time, and we can discuss about it.
Yes.
So in this case, we've just finished our experiment, right?
Yes.
Good job.
Thank you.
You too.